All right. Shh. So, page 13. Now, before I get into page 13, I want to show you guys how to take a cube root in your calculator just really quick, just so you know what to do. All right. Now, and it's frozen, of course. Now, your first instinct is to probably use the square root and try and put a 3 next to it. So, like, do the second key and that. Don't do that. All right. If you use the square root key, it automatically locks that little number or the index next to that root as a 2. All right. It's not going to change to a 3. What you do, however, is go to the math key that we went to yesterday to convert to a fraction. So hit the math key, which is right below that green alpha key. Now, do you guys see right here, number 4, where that's a little 3 and like a little root? That's the cube root. So if you click 4, it'll input a cube root for you. And then you can put whatever number you want. So let's say you did that big number like 8 to the 5th. So let's say that was 32,768. 32.
What page are we on?
13.
Thank you.
Or let's say you did it with the 8. So math 4, 8. All right. Now, another way that you can do it is if you hit the 3, so hit 3 first, then hit math, and then do you see right here where it says 5? It has like a little X. All right. You can input any number you want for that value, but you have to hit that value first. So I'm going to hit 5, and notice how I made it a cube root. So let's say I wanted a 4th root. I'll hit 4, math, 5. I now have a 4th root. All right, so you can literally input any root you want into the calculator. You just got to make sure that you go through the math setting. All right. Does everyone understand that? All right. So I just wanted to make sure that you knew how to do that because you may need it a little bit for today. Boys. Shh. All right. Now, solving radical and rational equations. So by rational, the rational equations that we're talking about are not necessarily true rational equations, which we'll do later on this unit. It's more so rational exponents. All right, so it's really just all radical equations. Now, equations involving square roots arise in a variety of contexts. All right. Now, the key to solving these lies in the application of inverse operations. Who remembers what inverse means? Owen.
It means like operations that are the opposite of each other.
Right. So opposite operations. All right. Just like how addition and subtraction are inverses of each other, multiplication, division are inverses of each other. What's the inverse of a square root? A square. Good. So that is typically the key to solving these, taking a square root and squaring. So when we were solving quadratics in the last unit, we were trying to get rid of the square, and we did so by taking the square root. So how do you think I'm going to get rid of the square root?
Is it something that's what is that?
You square it. So
I said that.
you said multiply.
On God at the same time.
No, it's not.
You square, you more. at the end, you multiply.
Technically. So for letter A, all right, how do you think I'm going to get rid of that square root? So to solve for x, the only thing I need to do is get rid of that square root. How do I get rid of it? Square it. So I'm going to square both sides. So the square and the square root cancel out. I have x is equal to 7 squared, which is what? 49. And is it not true if we plug 49 back in for x, the square root of 49, 7? So is the square root of 49 7? Yeah. So that's a very, very basic one. All right. Now, this next one. What's kind of the issue here? The fractional exponent. However, we learned yesterday how to handle that. A fractional exponent of 1/2 is the same thing as a what? Nope. Look at your notes from yesterday. Fractional exponent of 1/2 is the same thing as what? Nope, I'm not talking about a number. So anything raised to the 1/2 power is the same thing as doing what? It's in the stuff from yesterday. Come on, guys, it's in your notes. I'm not telling you. Anything raised to the 1/2 power is the same thing as doing what? Taking a square root. Thank you. So, anything raised to the 1/2 power, remember, it's the same thing as taking a square root. So, the very first thing you should do is rewrite this exponent as a root. So, since it's powering to the x minus 3, that means the x minus 3 is under the square root. You gotta know that anything raised to the 1/2 power is a square root. All right, that's why we did a good chunk of those yesterday. So now I can solve the equation. Now, can I take a square root right off the bat? What do you guys think? Or do I need to add the 3 over? Let me ask you guys this. That 3 is under the square root. Can I touch it? I can't touch it till I get rid of that square root. All right. All right, it's the same thing as like right here. Remember SADMEP? All right. So remember we talked about SADMEP in the previous unit. And what is SADMEP? PEMDAS backwards. SADMEP is how you solve equations. So technically, the x minus 3 was originally in parentheses. If it's under a radical, that's technically parentheses. You can treat it as such. All right. So a radical is technically an exponent, as we know, because 1/2 is a radical. So we have to take care of the exponent before we take care of parentheses. So how do I take care of the square root? How do I take care of the square root? We literally just did it. Oh, good Lord, this is like pulling teeth. How do I take care of the square root? You square it. Square both sides. So that's gone. I got x minus 3 is equal to what? 25. Now I can finish solving for x like normal. So what do I do next?
Add 3 to both sides.
Add 3 to both sides. So x is equal to what?
28.
28. Now, you always got to make sure to check your answer for what we call extraneous solutions. All right, and we'll get more into that in a second. But what an extraneous solution is that basically it's a solution that when you plug it in, it's not going to work. And it does happen. Basically what happens is that it'll make it undefined. Now, think back to the last unit. What if we plug back that 28 in for x? Obviously 28 minus 3 is 25, square root of 25 is 5, so it works. But what cannot happen under a radical? So we learned about a very special new type of number in the previous unit, but that only really happens with quadratics. So what cannot happen under a radical if we're trying to solve a radical equation? We cannot get a what under a radical? Nope, we can have decimals. We can have fractions. You can have exponents. What type of number did we learn about in the last unit? We learned about irrational, but there's another type. Imaginary. How does an imaginary number come about? What happens? Nope. Imaginary numbers come from having a what under a radical? A negative under a radical. That's what we can't have under the radical. If we get a negative number under the radical, we plug our answer back in, it's extraneous. Because we're getting a real number answer. So we can't get imaginary there. All right. Now we're not there yet where you have where you really have any extraneous, but just kind of get in the habit of doing it now. All right. So letter C, do it on your own. It's pretty much the same process that we've been doing for the last one. So I'll give you a hint. You want to start by doing what? Squaring both sides. Start by squaring both sides. Get rid of that radical. Then from there, it's just a nice little two-step equation.
Go ahead, Ben. What have from Cato is wearing this week.
You're on the wrong packet. This is
I think this one's gonna end up being a fraction.
Oh, wow. Oh. Crap, I thought I was,
All right, guys, you're a lot of talking, so I think you're done. Let's go over it. What's my first step? Square both sides. So I'm going to square this radical, and I'm going to square this 4. So the square cancels out the square root. So I'm left with 2x minus 1. What's 4 squared? 16. Now from there, this is why I let you do it on your own. It's just a two-step equation. So we add 1. I get 2x is equal to 17. And then do what? Divide by 2. So x is equal to 17 halves. You can just leave it as that fraction, or if you did put in your calculator, that should be 8.5. So I would have taken either one of those. How'd you guys do?
Good.
All right, good. Now, let's look at letter D. So we got that fractional exponent again, but we know anything raised to the 1/2 power is technically a what? Oh my God, we literally just did this. Anything raised to the 1/2 power is technically what? A square root. So the first thing we want to do, rewrite it with the square root instead of the fractional exponent. What is the only thing that should be under that square root? What is the only thing that the 1/2 is affecting? Not the 3x, just the x. Why is it just affecting the x and not the 3x? What are we missing? Parentheses. If it was affecting the 3 as well, it would look like that. But it's not. It's only affecting the x. So the 3 stays on the outside. So we have 3 square root x minus 4 is equal to 20. Now, this one is where SADMEP will come in handy. Because here's my question. What is technically the first thing I got to take care of? The -4. Good. So I cannot square yet because I have things outside of that radical. If you have stuff being added, subtracted, or multiplied outside the radical, you got to take care of it first before you square both sides. So the first thing I got to do, I got to take care of this -4 because that's subtraction. So I have to do what to both sides to get rid of it? Add 4. So I have 3 square root x is equal to 24. So we took care of the SA part of SADMEP. What's next? Can't square yet, because what comes first? So squaring is exponents. What comes first, though? What comes before the exponent SADMEP? Division, multiplication. Do I have anything being multiplied here? Absolutely, that 3. Okay, so yes, Rajon, you were correct. So it is the 3. The 3 is technically being multiplied here. So how do I get rid of it? Divide by 3. So this would be the square root of x is equal to 8. Now what can I do? Square both sides. So x is equal to what? 64. So guys, the ones that we've done so far, the radical was already by itself. But in that case, the radical was not. So we had to get it by itself. So again, in your head, especially when it comes to these, because the question always is, when do I take the square? So when do I square it? The answer to that, not until you take care of everything outside of the radical. Yes, sir. Yeah. Let's try another one. So think SADMEP. If it helps, just write it down every time, just so you have it, and you can cross stuff out as you go along. What do I have to take care of first if I'm dealing with SADMEP? The 7, which is what operation? Right, it's plus, so it's addition, but technically we subtract to get rid of it. So we got to take care of that 7 first, or the addition. That goes away. So we're done with the SA parts. This is 2 square root x plus 5 is equal to 6. What's the next part of SADMEP that I got to take care of? I got to take care of the multiplication. Do I have any? Yeah, what is it? The 2. How do I take care of it? It's multiplication, so to get rid of it, I got to do what? What's the opposite of multiplication? Division. So we divide by 2. Guys, you're overthinking it. So it's the square root of x plus 5 is equal to 3. All right. Now we're at exponents. So that means we can get rid of the square root. So what do I do next? Square both sides. I'll take care of the exponent portion. So this is x plus 5 is equal to 9. And then finally we have the parentheses, which was what was under the radical. So what's the last thing I got to do to solve? Minus 5. X equals 4. So you should be able to cross out everything in SADMEP. Now, sometimes if it doesn't have that operation, you can just immediately cross it out. So for example, let's say you didn't have that 2 in front of it. You can go ahead and cross out the multiplication division parts. All right, but this should be what you're doing when you're trying to solve these. Okay, at least until you get decent at it. All right. So using that same process that we just did, do letter F on your own. So my recommendation, write down SADMEP and cross out as you go.
Bro, this kid just told me to be dogging on Tinder. I didn't say that. He says it's but word to your mother. Word to your mother. You said boys? Yeah, bro, yeah. You're asking about to get killed. Oh, 12. I got a little bit over it. I've already been working. She could have been making a lot of money. I had I was 3 hours from overtime. And then this week I work every day. I'll be in overtime. So, and over those 2 weeks, I don't know if I get paid. Not this Friday. I don't know if I get paid next Friday or the Friday after that. We're just about to do like $1,000 paycheck. Just because how the weeks were hired. It's only gonna be like that for my first one because they got paid as soon as I got in there on Friday after the training. So everybody get paid for the training. Yeah, so all since day 1 of training.
All right, guys, let's go over this. So let's go with. Let's go with Riley E. What's my first step? Add the 4, good. So in SADMEP, that's the SA part. So this is 5 square root 3x minus 2 is equal to 40. All right, what's my next step? Riley M. Divide by 5. That's the MD part of SADMEP. So square root of 3x minus 2 is equal to 8. All right. What's my next step? Caden with a C. Square both sides. Good. That goes away. I get 3x minus 2 is equal to 64. And then from there, it's just the two-step equation. So I add 2 to both sides. 3x is equal to 66. And divide by 3. X is equal to 22. How'd you guys do? Pretty good? Good. Now, last one I want to do in this section is letter G. Because what's kind of the glaring difference here than what the ones we've been doing previously? It has a cube root instead of a square root. So keep in mind the type of root that you're doing. Because just like how a square undoes a square root, what do you think undoes a cube root? A cube. So instead of squaring it at the end, we're going to cube it. All right. So we're going to start by subtracting the 5. So this will be the cube root of x minus 7 is equal to 4. Now, to get rid of the cube root, we have to do what to both sides? Cube it. So keep in mind what type of root it is. All right. So this will be x minus 7 is equal to 64. And you could have just put that in your calculator, but for time's sake, I'm just going to tell you what it is. And then you just add the 7. So the process is still the same. It was just a different type of radical. So x is equal to 71. Yes. Yeah. So again, just make sure you pay attention to the type of radical that you're going to have. All right. Now, sometimes what arises is a more complicated scenario where you have a radical equal to a linear equation. All right. So these are really basic ones. So we're going to solve this system graphically first and then algebraically. So in other words, Desmos, but you don't have to take Desmos out right now. So we're just going to graph. So I'm going to start with the linear. So y equals x plus 1. So if you remember how to graph a linear function, so y equals mx plus b, what do you graph first? Who remembers? So linear function, that's y equals mx plus b. This is math 1. What do you graph first? The b value, which is 1. And that represents my what? Y-intercept. Now, how do I get the rest of my points easily? Can I just do rise over run? What's my rise over run? 1 over 1. So I'm going to up 1 over 1. So you're basically just doing this. I'm just going to fill it all the way in. So this is my first graph. Now, for my square root graph, we're just going to make a table. So let me ask you guys this. What is the lowest number that I can have under the radical? Not like what to plug in for x, but what's the lowest number I can have under the radical? It'd still be real. Lower. 0. All right. So I want to get a 0 under this radical. So what do I need to plug in for x to get 0 when I evaluate? So in other words, what number added to 3 gives me 0? Negative 3. So that's my x value first. And what's the square root of 0? 0. So this gives us the square root of 0, and that's 0. And then I'm just going to go down the line. So I want square root of 1 now. So what number plus 3 will give me 1 under the radical? -2. And then the square root of 1 is 1. What's my next perfect square after 1? So 1 is a perfect square. What's the next perfect square? Not 2. 2 is not a perfect square. 4 is the next perfect square. So I want to get 4 under the radical. So what plus 3 will give me 4? 1. So that's my next x value. And the square root of 4 is 2. All right, we got enough room for one more. So what's my next perfect square after 4? Not 6. Well, technically that's the next x value, but what's the perfect square I was going for? Perfect square, guys. So if I take a square root, it gives me a nice number. What's the next perfect square after 4?
9.
9. So 6 plus 3 is 9. Square root of 9 is? And those are our points. So this is what my graph will look like. I have -3, 0, -2, 1, 1, 2, and then go all the way over to 6, and then 3. So a square root graph looks like this, and we'll do more of this later. All right, now, if this was like a question, just put it in Desmos. All right, but for right now, I'm only showing you how to do it by hand. But again, like if this was like a question, put it in Desmos, generate a table. So graphically, what's the answer? So where's it? How do I know where my answer is to the system? So if we're solving a system of equation graphically, what am I looking for as the answer? Where the two lines what? Intersect. So where they intersect at what points?
1 positive 2.
1, 2. That's the point of intersection. So if we solve this system graphically, the system solved at the point 1, 2. Now, let's say that we're going to solve this system algebraically just using x values. So we only want the x value using substitution. So in other words, we're going to set both of these equal to each other. So the square root of x plus 3 is equal to x plus 1. Now, don't worry about the right side right now. Let's treat it like we've been doing. So if we're trying to get the x by itself on the left side, what's the first thing you got to do? How do I get rid of the square root? Square both sides. And by square, I mean put that in parentheses and square it. So I get x plus 3 is equal to x plus 1 squared. Now, think carefully about this. How do I figure out what x plus 1 squared is? And don't tell me x squared plus 1. That's incorrect. Think back to the last unit. This is technically the same thing as what? So this is technically the same thing as what? It's a perfect square trinomial. X plus 1 squared is the same thing as x plus 1 times x plus 1. So what do I need to do to expand it? Guys, what's your gut instinct to take care of this? What do you do? Oh, dear Lord. Box method. Thank you, Lord. You either need a box or foil it. So I'm going to do a quick box. So x plus 1, x plus 1. X times x, x squared. 1 times x, 1x. 1 times x, x. 1 times 1, 1. Combine like terms when I pull out, I get x plus 3 is equal to x squared plus 2x plus 1. That's what you need to do. Because now, what type of equation is this? Literally what our entire last unit was on. What? It's a what? Guys, what was our entire last unit on? Solving what? Quadratics. So how do I solve a quadratic? What's always your first step when you're solving a quadratic? You literally just took a test on this before spring break. Get one side equal to 0. Which side am I moving? X plus 3. So I'm going to subtract the x over, subtract the 3 over. Make sure you're subtracting it to its like terms. So this would be 0 is equal to x squared minus x minus 2. Now, with these, I would check to see if they're factorable first. All right? So that's a big X. So if I do a big X, what goes on top? A times C, which is negative 2x squared. Good. What goes on the bottom? All right, we know these two are going to have x's. So what are two values that multiply negative 2, add a negative 1? If we're multiplying to a negative number, that means one of my values has to be what? Negative. Multiply a negative 2, add a negative 1. What are the only factors of negative 2? 1, 2. Which one has to be negative? The 2 or the 1? The 2, because we're adding to a negative 1. You want me to do reverse box or T method? All right, I'll do T just for difference. So I have x squared. And remember, you're replacing the x with these two. Minus 2x plus 1x minus 2. Draw my T. What's my GCF of the first group? X. What am I left with? Come on, you guys did great on this part. X minus 2. What's my next step? Bring down the sign. So I bring down the plus. What's my GCF of this group? 1. Left with x minus 2. Since these are the same, we did correctly. What is guaranteed one of my factors? X minus 2. Those go away. What's left over? X plus 1. Still equal to 0. So how do I solve? What's the last step? You guys did amazing on this section when you took the test. Come on, you got it. Set them both equal to 0 and solve. So x is equal to what two numbers? 2 and negative 1. Now, hold up. Oh, that should be a positive x. Oh, crap. That's a negative 1. So. Okay, my bad. So these factors are actually supposed to be x plus 2, x minus 1, because I screwed up. So it's an easy fix. You just got to flip signs. So your answers are positive 1, negative 2. That was my fault. Now, what's kind of the problem here? So when we solved it graphically, what was the only x value that worked? So this is the point. So this is the point xy. What's the only x value that worked when we solved it graphically? Come on, guys. What's the only x value that worked when we solved it graphically? What's the x value at this point? 1. Yeesh. All right. But didn't we get 2 x values that should work when we solved it algebraically? Yes, something's not right. What happened is that we have what's called an extraneous solution. In this case, it's x is equal to -2. Which means if I plug it back into the original, so the square root of x plus 3, so this would be 2 plus 3 is equal to 2 plus 1. All right. What's 2 plus 3? 5. So this is the square root of 5 is equal to... Are those two numbers equal? No. So this is a case where we solved it algebraically, where yes, it worked when we solved it algebraically, but when we plug it back in, it doesn't work. It's not true. So that's why x equals... Oh, Lord, I totally did that wrong. -2. That should be 1. I'm sorry. Square root of 1 is just 1. Still same outcome. It's not the same thing. Is 1 equal to 3? No. Still not the same thing. So you know what you do with an extraneous solution? You just throw it out. That's why you got to check to see if your solutions work. All right, because sometimes they don't. And it's just this quick thing of just plugging it back in for x. All right. So let's try another one of these. Let's just go for the gusto and do letter B. First things first. All right, I need to get the radical by itself, so I need to move the what? I need to move the -2 by adding it to both sides. So this would be 2x plus 2 equals the square root of x plus 6. Now, since we got the square root by itself, what can I do next? Shh. Since I got the square root by itself, what can I do next? Square both sides. That goes away. I have 2x plus 2 squared is equal to x plus 6. Now, how do you take care of this right here? You have to do what? 2x plus 2 is the same thing as what? Times 2x plus 2. So how do I expand this? We literally just did it. Box method. So if I do a quick box, 2x plus 2, 2x plus 2. 4x squared plus 4x plus 4x plus 4. So this would be 4x squared plus 8x plus 4 is equal to x plus 6. Now, we're solving a quadratic, so what's the first step? Get one side equal to 0. Which side am I moving? The x and the 6. So I'm going to subtract those to both sides. This is 4x squared plus 7x minus 2 is equal to 0. Now, there's no GCF, so I can go straight into big X. Guys, just so you know, like when you guys were doing the solving quadratics by factoring, you beat my honors kids at it. You did better than my honors kids at it on the test. All right? Just a little, you should be proud of yourselves. Just a little esteem boost, okay? You honestly did better than my honors kids. All right. So, what goes on top? Negative 8x squared, a times c. What goes on the bottom? 7x. Both these are going to have x's. Two factors that multiply to negative 8 add to 7. So if we're multiplying to a negative, one of them has to be positive, the other one has to be negative. Nope. Multiply to negative 8x. All right, so let's list factors of 8. What are the factors of 8? 2, 4, 1, and 8. Now we're adding to a positive number, so that means which one has to be negative? The smaller one, right? So which one adds to 7? 1 and 8. Yes. Yeah. Now, since I did a T method on the last one, I'm going to do a reverse box for this one. Stop talking. So 4x squared, negative 2. And then the other two go here. So negative 1x, 8x. And then we're going to find my GCF of each row and column. What's the GCF of the first row? X. GCF of the second row? Not negative 2. 2. Because the first box is positive. So that means we can keep it positive. GCF of the first column? 4 what? 4x. GCF of the second column, keep in mind the first box. Negative what? 1. First box is negative. Besides that, there's no other GCF. So my two factors are 4x minus 1 and x plus 2 equals 0. Set them both equal to 0 and solve. X will equal negative 2, and then x will equal positive 1/4. Now, we got to check to see if any of them are extraneous. So you need to take a minute and check by plugging back into the original equation. So I'm going to check x is equal to 1/4 first. So I have 2 times 1/4 is equal to the square root of 1/4 plus 6 minus 2. 2 times 1/4 is 1/2. Then I have 1/4 plus 6, so 6 is 24/4, so that would be 25/4. So the square root of 25/4 minus 2. So that'd be 1/2 of, again, you can just put that straight into your calculator, see if you get the same number. But that would be 5/2 minus 2. So 2 is 4/2. So I have 1/2 is equal to 5/2 minus 4/2 if I convert. So 1/2 is equal to 1/2. So does x equal 1/4 work? Yes, we get the same thing. So that solution works. Let's check x equals negative 2. And again, guys, it could be as easy as just putting it into your calculator really quickly. Okay? So for x equals 2, let's put that in my calculator. So we know that 2 times negative 2 is what?
Negative 4.
Negative 4. So I'm going to put this side in my calculator really quick. So I have the square root of negative 2 plus 6 and then minus 2. Or is it add 2? Is it plus 2 or minus 2? Minus 2, yeah. It's 0. Is negative 4 equal to 0? Is negative 4 equal to 0? No. So x minus 2 is extraneous, so we just throw it out. It's not part of our answer because it's extraneous. So our solution is x equals 1/4. Now, guys, let's be honest here. If this was the test and you didn't remember this step, what can you do? What is always your friend? Desmos. So, the way you can put this into Desmos is set this side as y equals, set this side as y equals, and find the point of intersection. Do I still think you should at least try it by hand? Yes. But if you're desperate, Desmos. So like, let's just check in Desmos real quick. And you don't have to do this. I'm just going to write it in. So I have y equals 2x and y equals the square root of x plus 6 minus 2 on the outside. So if I zoom out a little bit, I didn't type the 2, I know. There it is. So remember, Desmos marks points of intersection automatically for you, which is right here. Now, if we're solving for x, what's the only part of the point I'm using? You only got to use the x value, which is 0.25. Is it not true that 0.25 is the same thing as 1/4? Yep. So that's all it is. So that can always be your last resort. Use Desmos. And you can use that for any of these equations. Now, last thing, we're almost done. This is quick. Okay. Last thing is fractional exponents where you have both a power and a root. All right. So the way you take care of these is if one radical is in the problem, isolate to one side of the equal sign. If two radicals are in the problem, put one side to each side of the equal sign. All right. Now, if you have opposite powers, remove the radicals. Or use a reciprocal power to remove the fractional exponents. All right. So let me show you. So for this one, 3/4, we could transfer it to a radical, but I don't want to. I'm going to leave it as a fraction. So I need to get that x to the 3/4 power by itself. So what do I need to do first? Think SADMAP. What do I take care of first? The -7. So this 2x to the 3/4 is equal to 16. Now, what's next in SADMAP? What do I take care of? The multiplication. So I have to do what? The 2 is the multiplication here. How do I get rid of it? Divide both sides by 2. X to the 3/4 is equal to 8. Now, this is where it differs. So I'm going to raise this to the opposite power, which is just a reciprocal. So what does it mean for it to be a reciprocal? Reciprocal means to do what to the fraction? Flip it. So the reciprocal of 3/4 is what? 4/3. So I'm going to raise both sides to the 4/3 power. Because what happens is this cancels out. Because if you multiply them together, by power rule, it becomes 1. So I have x is equal to 8 raised to the 4/3 power. And to be honest, just put that in your calculator. All right. So in my calculator, I'm going to do 8 raised to the, I'm going to put parentheses, 4 divided by 3. My answer is 16. So x is equal to 16. Does that make sense? Kind of, sort of, maybe. All right. So, yeah. I'm going to call it there for today. All right, so you do have a new Delta math. It's relatively short. All right. Now, guys, while you're doing these, please try to do them by hand. But if you get stuck, you're more than welcome to use Desmos. All right, but at least try to do. So, guys, my expectation, the hard ones, I don't care if you use Desmos. All right, but my expectation is that you can at the very least solve the ones that we did first by hand. So these, I expect you guys to at least know how to solve by hand. Now, the ones that we did like this, I expect you to at least know how to do it in Desmos. If you can solve it by hand, awesome. But if not, it's okay. Use Desmos. But at the very least, you need to know how to solve these by hand, the easy ones. All right.
You have a dry erase spray.
Oh, what?
The dry erase spray.
It's over there on that white shelf.